Well, my dear participants, I'm going to continue on my lecture. So first, this was the source file. Now I'm coming on the, I don't remember that where we were discussing. Probably matrix operations we have already covered. Probably these things were covered. Fitting of, क्यों जी डॉक्टर साहब हम लोग यहाँ कहीं थे
Perhaps,
कुछ
yes,
याद
sir.
है हाँ
Yes,
Yes, perhaps.
नहीं ये
sampling.
replicate I was talking about the replicate function.
Right.
Actually replicate is the function in R which is for sampling distribution. Actually in sampling distribution what we do, we randomly simulate data from some distribution and then we define a function, and that is known as sampling distribution. At BSc at UG level we have a full paper on sampling distribution work. And theoretically sampling distribution is a difficult thing. But here, because of simulation approach, we can simulate data from any distribution and we can make use of this tool. Basically, it is a kind of bootstrapping. The function replicate is used for sampling distribution of a statistic. For example, the student's t distribution is well known. It is well known that if x follows normal 0 and y follows chi-square distribution with 5 degrees of freedom, then a function of this x and y. X, this is a normal 0 1 divided by square root of chi-square divided by the corresponding degrees of freedom, follows t distribution with 5 degrees of freedom. We can implement in R using the replicate. The historical background of this student t distribution, I would like to share that basically student was William Seeley Gossett, and he submitted his paper in 1907 on t distribution to Biometrica. But his company, he was working in a brewery company at Dublin. So company did not allow him to make any communication in his own name. So he preferred to write his pen name as a student. So that is the reason behind student t test. And actually he used t distribution at a sampling concept, the simulation concept, to make the sampling distribution of t distribution for correlation coefficient. So that has the history of simulation. During those days, simulation was very difficult, but he did it. Here, T5, this is an object, replicate. We are simulating 10,000 observations, and this is the expression. This is random observation, one random observation from normal distribution, and then square root of chi-square, one random observation from chi-square distribution with 5 degrees of freedom divided by that. So this expression we are writing here, and this will be replicated. This will be repeated 1,000 times, and we have this result, and I can show you these things live also on the screen. देखिए जरा, हमने पहले भी दिखाया है आप लोगों को इस तरह की चीजें, यहाँ भी हम दिखाएंगे. See, this is the, this is the R chunk, fig.cap. This is the caption of the figure, and this is the to replicate, and this is the expression, and this is the histogram which we are making from those simulated observations. And prob is equal to true means it will report the relative frequency, the value of the density, so that we can add a t distribution with 5 degrees of freedom. This is exact t, and add is equal to tree makes this curve actually to add on this existing curve as histogram. I'm running these things. See, this is the result. This histogram is made on the basis of simulation. We can see the results of simulation here also. Just type T5. So these are the simulated observations which we have simulated. Now making use of these simulated observations, virtually we are making a histogram, and that histogram, this is T5. That histogram actually is being made here by using the command hist, and then we are adding this curve exact. This histogram is made on the basis of simulated observations. Understand? And this is the curve of the exact t. If these two match, that means our simulation is correct. So dt stands for, d norm stands for normal distribution, value of the density of normal. dt means it is the value of the density at t, and actually this expression with degree of freedom 5. Whenever we use curve here, x decides that what should be on x-axis. So on x-axis, actually these are the values of the quantile of t5, and add is equal to true. This makes it lower level because we want to add on the existing, on this existing. We can run them one by one also. देखिए, ये हो गया histogram, and now sorry, ये हमें एक साथ ही करना पड़ेगा क्योंकि आर मार्क डाउन में ये जरा रहता है कि सब चीज एक साथ होनी चाहिए. ठीक है, all the commands they are being run and we are getting this figure. So this way we are getting the result. Replicate, we can replicate, we can use this simulation tool for any sampling distribution, See, fitting a distribution using optim. Virtually we are going to fit. Fitting means is estimating the parameters of the model, and we can fit any model. Model is the mathematical construct actually which we want to fit. And frequency distributions here, it is a general purpose of optimization function which requires objective function to be optimized and guess value of the parameter to start. I always tell to the people that if I am assigned a job to teach only two functions of R, then I will prefer to use curve for plotting curves and T, because curve is also very general purpose function, and optim for optimization, because maximum likelihood estimation is a kind of optimization problem. Then least square estimation is also a kind of optimization problem. All the non-linear problems which are complex, they can be handled by the function optim. So moreover, Hessian is equal to true means the Hessian matrix, second order partial derivative of the objective function at optimum value will be returned. Note that negative of the Hessian matrix at the optimum value is known as Fisher's observed information matrix, and inverse of Fisher's observed matrix is termed as asymptotic variance covariance matrix. So we have first defined the function. This is NLLE, negative of log likelihood of exponential. The function is actually here. This is the keyword function for defining any new function in R. Theta is the argument of the parameter and y is the data argument. We are beginning. परसों सिंगल्स आप पूछ रहे थे ना कि साहब आपने सिंगल लाइन फंक्शन डिफाइन किए हैं, तो हमने एक एग्जांपल दिया. This also contains, you are just, this is the name of the function, this is the keyword of the function, these are the arguments of the function, and here this is this curly bracket like in C or C++. This is the beginning of the body of the function, and this is the end of the function. These are the different objects defined, and this is the value returned by the function. So what we are doing, this returns, these are the comments. This returns minus of log likelihood. Theta is log of scale, log of actually rate, not scale. LL is equal to DEXP, log likelihood is equal to value of the density of exponential at data point y, rate is equal to theta, and log is equal to true. So it will return log likelihood. And then we will get sum of those for each observations. It will compute individual value. So this LL will be a vector, and sum of that vector will be the value of the log likelihood. Return negative of the log likelihood because by default optim function minimizes. So we have translated the maximization problem into a minimization problem by returning negative of the objective function. Now simulate observations from exponential. Set dot seed just to simulate. We are setting seed because we want to simulate the same thing. We can reproduce the result. Y is equal to REXP. 30 observations are being simulated with rate is equal to 0.03. And these are the observations which are being simulated. Now we are fitting this. The function is optim. Par is the guess value. We start iteration. Although we know that the exact value is 0.03, but here we are guessing this. Fn is the objective function to be minimized. Fn is equal to NLLE, the function which we have defined here. Hessian is equal to true means it will return the negative of the Hessian matrix, because function is our objective function is returning negative value, so it will return the Hessian matrix, second order partial derivative, which is a difficult task mathematically, but here it will return y is equal to y. Actually, this part decides the value to start with for iteration, but remaining arguments are to be added. Y is the data, so y is being added here. Y is equal to y because this y is the second y and the first y is the name of the argument which is here. So method is equal to LBFGS. I will talk about lower is equal to, this is the lower limit of the parameter and that is 0.01. We are just guessing. There are several methods available with optimum function, and virtually Newton-Raphson is not very popular among the optimization function users. Although in mathematics, we give a lot of emphasis to Newton-Raphson method, but here in real optimization problems, we do not prefer, because Newton-Raphson method has certain problems. One thing is that if your guess value is not close to the optimum value, it will not converge, it will overflow. So that is the problem. People don't guess properly. But here, there are several 3-4 methods. We can see those things here, args. You can have args, optim. You can see all the arguments of the function. This is a very short way to look into the arguments of the function. Args, see. Here, par, fn we have taken. This is to provide the first order derivative gradient, which if you put null, that means it will numerically differentiate. Method is equal to Nelder-Mead method, then BFGS, CG, LBFGS, SANN, simultaneous annealing method, Brent. So we are not using Nelder-Mead method is a kind of simplex method. We are not going to use that. So here we are using this one. This is the best for us. Lower is -infinity, upper is +infinity. Actually, control Hessian is equal to true because we want Hessian matrix to be returned by the function. So these are the things, and we have used these.
Sir,
Yes.
Sir, please zoom in your screen, sir, so that we can have a better visibility.
अब नजर आ रहा है इस वक्त यहीं नहीं, यहाँ पर हम जूम करें थोड़ा सा।
जी हाँ सर, जूम कर दिए अपने स्क्रीन को सर। जी हाँ सर।
अच्छा, चलिए अब हम यहाँ आ रहे हैं सीधे।
ठीक,
इसी बारे हम यहाँ से दिखाते हैं। वो तो हमें कमांड दिखानी थी थोड़ी, इस वजह से मैंने खोला था वहाँ, है ना, क्योंकि ये सब चीजें जरा एक साथ दिखाना मुश्किल हो जाता है। Here things are clear. I have already, once you run this, actually this lower is equal to, हो रहा है ना, अब तो नजर आ रहा है ना साफ, क्यों और बड़ा करें? अब हो गया ज्यादा क्लियर? आसिम साहब, हेलो।
यस सर, क्लियर है
ना? हाँ चलिए ठीक है। HTML फाइल से ज्यादा आसान होता था दिखाना, वरना PDF भी है हमारे पास इसका, लेकिन PDF के मुकाबले में ज्यादा बेहतर रहता है, क्योंकि यहाँ सीधे these are the commands in gray color and these are the outputs. So when you run this, actually many things will be assigned to this object M1, and if we will extract, see here method is equal to LBFGS, and this is the method which was developed by 4 authors. ये हैं इसके चारों author में लास्ट author, फर्स्ट author is ब्राइड, और ये है गेलफ्रीड राडी, लेकिन लास्ट author मैं श्योर हूँ शी शन्नो. So these are the 4 authors who published independently in 1970 this method of optimization. This is a variant of virtually Newton-Raphson, which works better. And lower bound for the parameter which is to be optimized, here you have to give a lower bound so that it will optimize after 0.01 only, and that is positive virtue. So here after the whole thing is assigned to this object M1 to extract the maximum likelihood estimate, use dollar operator, and you will get the value, and the value is 0.027. See, our exact value is 0.03 from which we have started our simulation. Here, we are estimating the asymptotic variance. This is a very powerful tool. The property of maximum likelihood provides this estimated tool, which is very useful for theoretical implementation of the results using ML. And this has been the reason behind popularity of ML method, that we can always get this asymptotic variance covariance matrix, and we are taking a square root. See what we are doing. This is square root of what? Of diagonal element of what? Solve stands for inverse of the matrix, and the matrix is the Hessian matrix. This is the second order partial derivative. And negative is, we have already returned, so it will be negative of the Hessian matrix. We are getting inverse of that, and then we are extracting diagonal elements, and virtually we will take square root of that, so that will be standard error. So this is the standard error of the estimate. Now we can recognize them by using C-bind. We have already introduced out C-bind, column-wise binding, MLE estimate and standard error, C, and then we are giving the row names of this object. Row name is a general method of naming a row. Row name is rate, and then round the output up to 3 places of decimal. So we are getting the result, and this is 0.028 is standard error 0.005. This one. So this is the output we are using. Now making use of this optim, you can fit any standard distribution, and not only that, you can solve any problem of nonlinear optimization. Is it clear to you all? Are you following the things? Is it clear? Should I go ahead? Yes, I think.
Yes, sir.
Yes, thanks.
Yes, sir. Yes, sir.
Actually, we teach these things to our PG students also, because optimization problem is very common in most of the applications. See, comparing two group t-test, we have already talked about, but because if you begin with a very simple example, understanding of the things is much simpler. Although Romana Shaila has clearly explained these things in her yesterday's talk, but I am defining these things without those excellent plots. I am just using the t-dot test of the base. So here we are creating a vector. Scores obtained by the 5 students in batch A of AMU, X2, scores obtained by the 5 students of the score of batch A is same as batch B, and we are using the function t-dot test. X1 score X2, and we are getting the result. Here it is giving Welch test. Actually, there is a theoretical background of t-test is that we assume that variances of both the populations from which this data is being generated, they are same. The normal populations are same. If you do not put that restriction, then the theoretically this t-test becomes very difficult. And many people have contributed, including one Indian, he is P.V. Sukhatmi. He did that in 1922. And actually, this is another approximation to the t-test, and that is Welch test. So we have used that. This is the value of p-value shows there is significant difference between the two. This is the 95% confidence interval. And actually here, the differences. Here estimate of mean first and estimate of mean second. See, here I am putting that restriction. Normally, we make this assumption and we teach these things to our student that variances are equal. So we are forcing the additional argument where dot equal to true, so that the exact t-test which we teach to the students results will come. And this is the result. Again, it is significant, and here p-value is also, this is the value of t statistic, and the overall conclusion is that alternative hypothesis two differences in means is not equal to 0. 95% this is not containing 0, so that means it is significant, and statistically it is significant. Now here I am assigning the whole results. We have used this t-test and we are directly reporting the result. Here we are assigning this whole result to an object fit.t2. माफ कीजिएगा आप लोग, जरा मैं कुछ बातें करना चाहूंगा। हम्म? आ, आप लोगों को समझ में तो आ रहा है ना? आर यू फॉलोइंग द थिंग्स? See, why I am fan of, why I became fan of R, the reason behind that in 1997 we purchased SaaS package in our Agriculture University of Kashmir, where I was working as assistant professor. So there, we wrote to the India branch office of SAS that since we are your customer, you trained some of our faculty members. During these days, they gave us for just 1 lakh rupees in academic offer. The cost was 10 lakh during in 1997 for SAS. They wrote us in the reply that, well, we will train, but our charges will be 10,000 for a person for a day. So that means for training of a single person, it was costing 10 days training, costing 1 lakh the cost of the software. So my senior, Professor H. Mir, who was also an Algerian, he told me that, Khan Sahab, you have been behind the purchase of this software, and you know that we cannot make this payment, so why not you try to learn? SAS has 27 manuals, and its SATS manual itself contains around 4,000 pages during those days. So I started learning. I started reading the literature, and then what I did, I organized a training program after studying few days. And this teaching is one of the best way of learning the things. So what I did that I organized a training program, and in the first training program, 10 faculty, because space was very less, so 10 faculty members were deputed from the university. But after completion of that program, every faculty member was interested to join that program. And even our university gave us a special fund to organize these programs, and we were forced to organize 10 programs. But what happens after 1 year? That university was not paying the license fee. And because of licensing problem, we could not continue that. We raised this issue in one of the important meetings, that is Research Council meeting in Agriculture University we have. That meeting consists of every senior professor, every faculty member who has submitted some project. Vice Chancellor chairs that, finance officer and registrar, every official is there in that meeting. So I again raised that issue with the Vice Chancellor that, sir, we are spending a lot of money for running the cars of the officials, but we are not making the payment of 67,000, besides the fact that we are already signed an MOU with the India branch office of SAS. Then what happened? Professor Yusuf Kamal, he was an Algerian, he is no more now. अभी इनका मुझे लगता है किसी कोरोना में उनका इंतकाल हुआ बेचारे का. So he was an Algerian, he was DDG in ICR. He belongs to Kamalganj of Farrukhabad district. So he was our VC. Algerians are famous for humor. So he asked from the finance officer that why you are not giving this money to them. तो उन्होंने कान में धीरे से कहा कि सर, ये एक बार का दर्द नहीं, ये बार बार का दर्द है. हर साल हमें देना पड़ेगा, तो हम इसको अफोर्ड नहीं कर पाएंगे. What he told to me then in that big gathering, उन्होंने कहा, खान साहब, सास आपकी बहुत महंगी है, आप why not you bring a cheaper bahu? And virtually this kind of reply I was expecting. So I then suggested about S+. We purchased S+, and we trained our faculty members again, our students. But again, after 1 year, people started demanding a copy of the software or key, etc. It happens. जो खास तौर से जो लोग बाहर के लोग थे, कश्मीर से बाहर के लोग थे, वो लोग खास तौर से आए कि यार आपको तो की पता है, आप दे दीजिए. और हमारे जो चेयरमैन साहब थे वो इतने सख्त कि नहीं साहब, जो हमारी लैब में आएगा बगैर हमारी परमिशन के नहीं आएगा. And being a teacher, I was feeling a strong pain that the things which we are providing to the students, they are not able to enjoy that. So इसी दर्द में हमें तो 2003 में, in 2003, I was invited by ex-professor, director of ISI, J.K. Ghosh. J.K. Ghosh He is no more now. He is one of the big personalities in the field of statistics. He had been director. 6 months he was staying in India and 6 months in the Purdue University. So he invited some of the Bayesians from all over the India. So I was also one among them. There I shared this problem that I am training to the people, and I'm with Mohan Delempati. Mohan Delempati, he did his PhD um, from Purdue University, and he was professor in ISI Bangalore. So I shared this problem that I want that I should facilitate with the software also. मैं इसको दूसरे अंदाज में कहता हूँ कि बिटिया अगर ससुराल में है तब भी यूज कर सके और अगर मायके में है तो वहां भी यूज कर सके. हमें तो ऐसा आप कोई रास्ता बताइए. So he suggested me about. He told me that since you are familiar with the S plus, you can now learn. You can make use of R, because R and S plus, they are very close. So since 2003, I started downloading it, learning it, and in 2005 we published a paper in our Agriculture University Journal. That is a very big paper on agricultural data analysis with R. So since then, I have delivered many talks. Particularly, I am thankful to Banaras Hindu University people, but the Department of Statistics, they were inviting me almost every year to organize some workshop on R. And then certainly I got a chance to look into Pondicherry, in Guwahati University. These are my talks: Guwahati talk, BHU talk, Pondicherry talk. So many such talks I have. And every time I delivered some aspects of either simulation or data analysis, or this talk which I'm going to deliver, this is a fundamental talk which is required to understand any aspect of. These are the basic elements of the language. You know, R is a language. Learning of a language is very important. If you do not know, or language का मामला ऐसा है, you know, an Englishman came to Kashmir to learn a Kashmiri, and he actually he got a training from a Kashmiri professor of Kashmiri in Kashmir. After 6 months, he told to his teacher that, sir, I want to go back to England because I have become expert in Kashmiri. उन्होंने कहा अच्छा तुम कश्मीरी जो है वो सीख गए हो, एक्सपर्ट हो गए हो? कहा कि हाँ सर. कहा अच्छा सामने जो मुर्गी जो चुग रही है उसको जरा कश्मीरी में बुलाओ. And he failed to do that. तो उसने कहा कि हाँ साहब बिल्कुल सर मुझे नहीं आती कश्मीरी अभी. तो ये जबान का मामला है. हम 4 दिन में भी बहुत कुछ सीख सकते हैं और 4 महीने में भी नहीं. You know, one of the biggest man in R, he is Haley Wickham, a big name in data science. He himself tells that sometimes he is stuck in the way and he feels very bad. So जबान का मामला ऐसा है कि हम सीखते जाएंगे और लोगों को जो है वो सिखाते जाएंगे, लेकिन कभी कभी हमें परेशानियां आएंगी. लेकिन हम कहते हैं कि हमने तो सास को भी छोड़ा और उसके बाद, माफ कीजिएगा, हम सौतन का वर्ड यूज करते हैं एसपीएसएस के लिए. सौतन को भी हमने छोड़ दिया. देवर का टर्म हम यूज करते हैं मिनी टाइप के लिए. मिनी टाइप भी हमने छोड़ा और उसके बाद बहू एस प्लस लाया गया और उसको भी हमने छोड़ा और आखिर में हमारा अपनी अनारकली से प्यार हुआ. लेकिन आर के साथ जब आप थोड़ा सा कर लेंगे, शुरू में ये दुत्कारती है, लेकिन जब आप इसको सीख जाएंगे तो ऐसा दीवाना बनाएगी कि आप छोड़ नहीं पाएंगे. सो you must learn and you must enjoy these things, इंशाल्लाह. तो यहाँ पर मैं कह रहा था कि ये जो हमारा आउटपुट है, our output is very here. You know, those who have used SPSS, they might be knowing that when you run, you get many things in the output window. मैं कहता हूँ सौतन इतना कुछ दिखाने लगती हैं कि समझ में नहीं आता कि कौन सा अच्छा है कौन सा बुरा, क्या हम देखें, क्या निहारें और क्या छोड़ दें. But here it gives a brief output, and if you want, you can assign the whole thing to an object, and you can extract by names fit.to, and then whatever you want to extract, you can extract by using the dollar operator. So this way, like statistic, use dollar statistic, you will get the value of the statistics. Doctors say they want to know only p value. So what you have to do, you just use fit.to and p value, you will get the p value. See, again, since it is an object-oriented programming language, the name is same. T dot test. But same function was used for when there was no equality of variance. Then we used for equality of variance y dot equal. Now we are going to use pair T test. Pair T test actually here when observations come in pair form, like from the same person, if you are getting his blood pressure in the morning and then in the evening, although these are the two observations, but since they are coming from the same person, they are paired, and in that situation we have to use pair T test. The argument is paired is equal to true and it will return the result. Then using formula argument, C, C function we have already introduced. Here what we are doing, x1 is the score vector of batch A, x2 is the score vector of batch 2. C function again concatenate these two vectors together and see this is the vector, this is the whole vector. Batch A scores and then batch B scores, they are combined together. Here, we are using the function GL. GL stands for generation of level and factor. There are two levels, batch A and batch B, and 5 observations of each, and we are leveling them by batch A and batch B. So this will generate a factor vector. Factor vector is a categorical vector. Yesterday, probably Romana tried to explain factor vector is a very important concept, and actually factor vector is a categorical vector. And if your vector is factor vector, not numeric, it will be treated differently. If it is logical, it will be treated differently in R. So what we did, we generate a score vector, then we generated this factor vector, and then we are using the formula argument. Here, if tilde is there, that means we are using the formula argument. And here, score versus, this is the numeric vector and this is the grouping, and we are getting the same result. Now, I'm going to talk about, we have already talked about numeric vector. When the argument in C, they are numeric, it is numeric vector. If they are character string, it is character vector. If they are true and false, that will be the logical vector. They can have the complex values also, that will be a complex vector. But here, in all these, we are in matrix. The limitation of a matrix is that you can combine all the columns must be of same type. If you have some columns numeric and some columns character, the whole thing will be converted into a character. If some columns are logical and some are numeric, the whole thing will be converted into a actually logical. So here we want that the original character of the data object should remain. So here we are combining. A list is a collection of like and unlike data object. Like this one is numeric, this one is character string, and this is scalar. So all these things can be combined together, these things, and this is the concept of list in R, and this is LD, listed data object, and here they will maintain their own characteristics, and they are very useful from the purpose of organizing the data, manipulation of the data, etc. So here LD1, the first one is x1, s is numeric, names it is character string, and here it is scalar, the single vector. We can dump them by using the function dump, and we can sort them by using the function source. T-test with data frame. Data frame we have already talked. Those who are familiar with pandas, Python, they might be using the concept of pandas. Pandas is nothing but the concept of data frame. It is similar to the concept of data frame in R. So these are the similarities. If you know data frame, you can make use of pandas also. See, the data frame main thing is that it is a two-dimensional array, but it is a generalization of a matrix. Here one column is numeric, second one is character string. In a matrix, you cannot do that. You have to make both of them either character string or both of them either numeric. But here, it is again a two-dimensional array, but actually it can combine a numeric column with a character string, with a logical, with true, false, etc. So this is the concept of data frame. The function data frame, score is numeric, group is factor vector. We are combining them and we are saving them by the function write.table. The file text file is this one, print, and we are getting the result. Now t.test. Here score versus group, and actually this kind of structure we can have. Excel sheet is what? Excel spreadsheet is nothing but a kind of data frame. So that you can have. So this is the group column. And here our data is actually this data df1 is not a data file. The data file is this one, but this one is an object which has certain attributes. So we need that data frame to run this, and we are getting the result. So in a rectangular form, we can save our data and we can call that into var. The same things we are getting. Var.equal, again we are getting the same. Then graphic features, score versus, this one is numeric. If both are numeric, it will return scatter diagram, scatter plot. But here this one is numeric and this one is factor. It is a grouping variable. So in that situation, it will return the box plot. कल मैंने बात की थी final दीदार की. This is the final दीदार of the data. Although we have already seen that there is significant difference between, this is the median of the data, this is also the median. This box plot was given by the John Tukey, and it is a very informative plot. This distribution is symmetric. This is quartile 1 and this is quartile 3. This is quartile 2. And these are the whiskers. These are the whiskers. These are not maximum and minimum, although here they coincide with maximum and minimum. See here, this shows that this data is skewed and skewness is in the right. And the difference between these two seems very clear that they are significantly different. So this box plot clearly shows there is a significant difference between the scores of the two groups. The scores of batch B are higher than that of batch A. Moreover, scores in batch B are more variable. This length shows they are more variable as compared to batch A, whose box length is smaller. It is evident from the length of the box. So this represents centrality as well as variability present in the data. I have shown pair t-test. I don't want to discuss again. Now another way of creating data frame by using the function is stack. See, since most of you are computer programmers, you might be knowing about the concept of stacking a data. So in C, C++, everywhere you want stacking. Here, the function is stack in R to stack a data. This is a data. We have created a data frame. Batch A, this is the name of the column, is x1. This is the value of the vector. Batch B, the value of the vector, and this is the name. So this is a data frame. We want stacking so that the values of batch A and batch B, they should be stacked. सबसे ऊपर आ गया ये, यहाँ की values आ गई, और उसके नीचे फिर ये वाली values, and we are identifying them by the corresponding batch A and batch B. This is known as stacking of the data. This is stacking. This is a kind of data manipulation. कल ख्वाजा साहब पूछ रहे थे. ख्वाजा साहब.
सर.
हाँ, अस्सलाम वालेकुम. ख्वाजा जमाल साहब.
जी सर, सलाम सर.
सर, आप पूछ रहे थे कल कि डेटा मैनिपुलेशन क्या होता है.
नहीं सर, नहीं सर, मैंने ये पूछा था डेटा मैनिपुलेशन नहीं, जो डाटा हमने फीड कर दिया, सेव कर दिया, उसको अगर हमको दोबारा कुछ चेंज करना हो तो कैसे करेंगे, ये सब पूछा था मैंने.
अच्छा, मान लीजिए जैसे मान लें कि x1 आपका है, तो अगर हम चाहें उसमें उसके बदले log of x1 कंप्यूट करना.
जी अगर जी सर कोई चेंज करना हो डाटा जो हमने फीड किया है, अगर कोई हम चाहे रेक्टिफाई करना, कोई वैल्यू करेक्शन करना, वो कैसे करेंगे सेव डाटा के अंदर. ये सर
उसी फिक्स से आप जाएंगे उस शीट में, स्प्रेडशीट में. यास्मीन ने जवाब दिया था, उसको आप कर लें.
जी सर, जी.
लेकिन जो डेटा रैंगलिंग का जो कंसेप्ट है ना डेटा साइंस में, डेटा मैनिपुलेशन, डेटा रैंगलिंग, बेसिकली वो एक बड़ी चीज है. डेटा साइंस वाले उसको डेटा रैंगलिंग का टर्म यूज करते हैं. उसकी भी जबरदस्त फैसिलिटीज हैं आर में, है ना. उसकी भी जबरदस्त फैसिलिटीज हैं. जैसे मान लीजिए कि हमारे पास x1 x2 आ गया, हम चाहते हैं कि साहब उसका लॉग कंप्यूट हो जाए, और वो जैसे हम एक्सेल शीट होकर हम करते हैं. और भी बहुत तरह का, जैसे सी बाइंड, आर बाइंड, all these sort of stacking is also a kind of data manipulation. We have the data in the form of a matrix, and we want that categories should also be reported. So what I did is that here this data has been changed into this format. So this is a numeric vector, and this identifies the group. These are the values and IND. We want to change these by the names score and then group. So we use the function names, and we did that, and this is the output. Now we can save it, write that table Here, this read dot table and write dot table are very flexible functions. Understand? Here, this is the object file. You can have your file saved into the current working directory, or even you can save it on some folder on internet, है ना, कहीं भी अगर आप करना चाहें, जस्ट आपको यहाँ इसका पाथ देना है और वहां वो सेव हो जाएगा, और वहां से रीड डॉट टेबल के जरिए हम उसको पढ़ भी सकते हैं. से फॉर एग्जांपल हियर we are reading the data. This is the data frame which we have created. Now we want to read it. Reading means this data frame will be created by the function read dot table. Header is equal to true means the first line of the data is the header line. That is the name of the variable. So here we can read this, and that means creation of the data. If you have your data on some web page, so you have to just give the path here, HTTPS like that, and you can read the data from there directly. So these functions are very flexible. Now we are using, actually we want to print in a very nice manner. So we are using the function cable of knitr package. Knitr package basically is meant for documentation. जो हमारा R markdown है, इसके पीछे भी असली knitr package है, which recognizes all these things. So the function is, the package is knitr. We have installed require knitr, and then cable is the function. df1, this is the object, and caption of this one is, यहाँ तो हमें बहुत खूबसूरत नजर नहीं आ रहा है, देख रहे हैं आप, लेकिन क्योंकि HTML फाइल है, अगर हम इसका दीदार करेंगे PDF में, मैं वहां दिखाऊं कि वहां कैसा ये नजर आता है. देखिए ये है ना हमारा, देख रहे हैं आप, ये देखिए आप, द सेम फंक्शन, जस्ट हमने जैसे हम करते हैं रेंडर PDF, this is generating this kind of table which can be nicely added into any document. ये तो हमारा है, ये PDF जनरेट हो गया, ये बिल्कुल, it is because of cable function. So actually for typing these things you have to use LaTeX command, but here we don't need to that. It will automatically do. There is a PanDoc software which makes an interface between all these and which translates, and we are getting the result in this nice formatted form. ये देखिए डॉक्यूमेंट भी कैसा हसीन डॉक्यूमेंट है ना, इसमें कमाल भी है और हुस्न भी है, दोनों चीजें हैं, है ना. इसको आप किसी को भी भेज सकते हैं ऐसे ही. Now I'm coming on my own output. So here graphic features of the data, these are the numeric features. These were the numeric features. Now graphic features I've already talked about. This is the data, and this I have already talked. Suppose we have already discussed this, how to get this plot. Plot score versus this, and this gives the box plot, because if both are numeric, it will return a scatter diagram. If this one is numeric and this one is actually categorical variable, factor variable, it will return a box plot. To save it as a PNG file, what you have to do? You have to just, there is a concept of device in R. Device means your default screen is the device. It can be a file also. Suppose you want to generate this graph and we want to save it as a PNG file. So the command is this: use PNG, then this is the name of the file with extension .png. Here extension should be PNG. This should also be PNG. Then you run the command to get the graph, score versus this, and data is df1, and then you have to make device off. So this big box plot 1.png, this PNG file will be saved into your working directory. ये देखिए हमने क्या नाम रखा था उसका, देखिए ये PNG fig plot, ये देखिए fig plot. This is the fig box plot 1, fig box plot 2. ये देखिए आप, ये है फाइल, अभी आ रही है सामने आपके. थोड़ा सा टाइम ले रहा है ये आने में. ये देखिए आ गई फाइल, ठीक है, प्लेटफॉर्म। देखिए अब ये PNG फाइल है, इसमें और भी तमाम चीजें जो आप करना चाहें कर सकते हैं, ठीक है। यू कैन सेव इट एज, actually there are many other options. You can save it as PDF also and you can get the result. So I'm coming here, ये हमारा to save at PNG. Now say if you want to save it as JPG file, you have to write here JPG, then name the file and with the extension .jpg, run the plot, device off, it will close the device, and then only you can see that figure. Similarly here, to save it as PDF fig box plot, I have named the file .pdf, run the score, and again you have to off the device so that you can see that. So this way you can make your graphics independent of all this output. Although here we are not needing that because we are running them directly and we are getting the plot here. But if you want to save it as a separate file to call somewhere else, you can do that. That facility is there. Then analysis of variance. You know, here we are going to talk about, you know, in t-test we compare two populations in terms of means. In the analysis of variance, although it is a very broad tool, but here we are beginning with a very simple concept. If you want to compare, if you have the information on batch C, also how to compare in terms of average. The technique is analysis of variance, which was given by Sir Ronald Fisher in 1920. So again, we can combine them together. Score is equal to C. Earlier, we were having only X1, X2, now X1, X2, X3. So all of them will be combined and the vector will have all the three. Then here we are generating the factors with three labels, and these are the observations in each group. Label is equal to batch A, batch B, and batch C. And we will make a data frame, we will save them. And this is the data. This is the, earlier we were having only up to batch B. Now we have added the batch C information also. So this way we have made an object, and you know, we can have the names. Actually, there are many functions to see from for a data frame. Like, you know, I would like to come here, you know, DF2. This is a data frame which we have created. Suppose the data frame is big. तो हम कहते हैं कि साहब अगर आपको नाम जानना हो तो क्या करेंगे आप? नेम्स ऑफ DF2. आपने खाली नाम पूछ लिया तो क्या फंक्शन है? नेम्स. नाम जान लिया आपने, द कॉलम नेम्स, ठीक. अब आप साहब चेहरे का दीदार करना चाहते हैं तो क्या फंक्शन है? हेडर पार्ट, हेड DF2. देख लीजिए, हेड DF2, हेडर पार्ट देख लिया आपने, 6 ऑब्जर्वेशंस तक, ठीक है. सो दिस इज ड्यू टू हेडर पार्ट आपने देखा. अगर आप पैरों का दीदार करना चाहते हो तो क्या फंक्शन होना चाहिए? हेड इज टू लुक द हेडर पार्ट. व्हाट शुड बी द फंक्शन टू सी फ्रॉम द बॉटम?
It should be tail, sir.
इट शुड बी टेल. टेल जो है पैरों से दीदार करा देगा आपको, TAIL, टेल DF2. तो you can look from the bottom. Similarly, if you want to see only one column, then you can extract them. अगर मान लीजिए नहीं साहब हमें चाहिए कि नहीं साहब हमें चाहिए खाली 10th row or both the column. So DF2, you make extraction operator. है ना? Second column we have seen, if you want actually 1 to 5, 1, say for example, if you want to see the rows, first row, then third row, and then 9th row. So before comma means rows are being selected, and the column is, if you do not specify any column, it will select all the columns. So it will show you second row, third row, and 9th row. ये देखिए आपने देख लिया. And it can be assigned to another object, and you can. So these data manipulation tools, these data wrangling tools are very important in R. Suppose you have given 2, so it will report you about the second column of these rows. If you are giving, say for example, 1, it will report the first column. If you are not specifying, it will report the both. So these are the ways and means to look into the data. Actually, for data wrangling, data scientists talk in terms of these things. If you read any book on data science, like that written by Wilhelm and Ettels, there are many books which are written particularly for the purpose of data science using R. So there they have made all these things in a very nice manner. So I'm coming on. Here again, we are making use of analysis of variance, and we are getting that there is significant difference between the 3 batches. Here we report the function model.tables, type is equal to means. So we will report means, overall mean, then standard error of difference. These are the batch means, these are the standard error of differences. And Tukey HSD, yesterday, Dr. Yasmin Khan also talked about these things. So Tukey HSD is better than Fisher's LSD, and that's why it is default. The difference between batch B and batch A, here the p-value shows it is significant, whereas between batch C and batch A, it is not. So these numeric summaries can be nicely organized in the form of a graph. O par means we are giving the graphic parameters. Par stands for setting graphic parameters of the plot. So mar stands for margin. O par, we are setting a new margin. O par, old parameters. Mar means margin. Margin, there are 4 margins of a figure. This first margin, second margin, third margin, and fourth margin. Here we need a bigger space, so we have given 4 in the margin, 4 characters space in the margin in the bottom, but in the second margin we have space 10 because we want this much space. 3 character space on the top and 2 character space in the margin. And then we run this plot. Just simply the fitted object of this one to PHSD, this you can give to the plot to key, and LAS stands for actually this parallel to this axis, perpendicular to these axes. This is LAS is equal to 2. And you know, here the interpretation is very clear. This vertical line is the line of no difference at 0. So if this is crossing, if this line is crossing some confidence interval, that means that is not significant. So batch C versus batch A, it is being crossed by the line of no difference, vertical line at 0. That means this contrast is not significant. And we have seen it from the p-value also, that batch C versus batch A, p-value is greater than 0.05, so it is not significant. So graphically it is not significant, whereas this batch B versus batch A, it is the difference is positive and it is statistically significant because it is not being crossed at 0. And this difference, batch C versus batch B, the difference is negative and it is also statistically significant. So virtually in this plot, we are getting the confidence interval as well as hypothesis testing. So every important summary is being reported in this graph, and this is the excellent graph which we are getting. ये सब चीजें इतने स्मार्ट दीदार ये सिर्फ हमारी अनारकली के पास हैं, आर के पास. Now another plot par o par means return to the original settings. Plot score versus this, we are getting the box plot. You know, batch A scores batch B and batch C. Here these two are closer, but this one is higher. So the difference between batch A and batch B, it should be significant. Batch C versus batch B should also be significant, but the difference between batch A and batch B, it does not need to be significant. Actually, it is not significant. We have already seen in this plot also. Now, there is one more plot, and that is plot.design. देखिए, just it is the plot of means. This is overall mean. क्या है हमारा? We have extracted we have put the data frame object df2, and we are selecting the columns of numeric as well as one factor variable. So we are reporting. If you have more scores, that can also be written, but there must be one factor variable. So here, these are the means. See, this is the overall mean. Batch A and batch C, they have below average performance, and the batch B has above average, above average. So this is the interpretation. Now in regression analysis, again, here, Yasmin has already talked about, but I have shown these things, in a very simple manner, that how you can organize the data in the form of a data frame, and then you can save them to get the correlation, extract batch A score, batch B score. This is the correlation coefficient. Core.test is to test the statistical significance. These things have already been talked by. And this is the core Df3. This is the correlation matrix between the three columns. Batch A and batch A, it will be 1. Batch A and batch B, this is the negative correlation. So all these are, then you can round them, this matrix, to the 3 places of decimal. The function is round core Df3. It will be rounded to any place of decimal. If you have round only up to 0, it will report only integer values. Fit a simple regression model. The function is lm, batch A versus batch B. We are modeling, this one is the response and this is the input variable, and we are getting the result. See, ये एक दीदार हुआ हमारा. हम कहते हैं कि यहाँ पर एक फंक्शन है print. You get the summary, you get the output assigned to m1. Now how to look into the results? हम कहते हैं एक छोटा दीदार, and that is print. You give a brief output. एक बड़ा दीदार है, and that is summary. Here you have the detailed output. It is giving not only residuals, formula, residuals, then estimate of the analysis, and then residual standard error, and then R square, adjusted R square, and then the value of the overall statistic F value. So all दीजिए बड़ा दीदार है, लेकिन इसके अलावा एक स्मार्ट दीदार है ना? Actually, smart दीदार हम कहेंगे. These are the ways of displaying the results. So actually there is a package ARM. ARM is a package which was developed by, actually this is an implementation of a great book on data analysis that is due to Gilman and Hill. The title of the book is Data Analysis Using Regression and Multi-Level Hierarchical Models. That is a great book on data analysis, and that covers many aspects of data analysis. And they developed this package ARM to analyze the results. And the same, Gilman and his group at Columbia University is a very powerful group of data analysts. You know that the designation of Andrew Gilman is that he is a Bayesian also. He is professor of political science and statistics. One of his colleagues, John Raftery, he is professor of sociology and statistics. So they do interdisciplinary work, and they are designated like that. So they developed this package AM, which has the function. It has many functions. It is a very powerful package in R. You need to install that by using install.arm. And they used for simulation and other things. They have developed a function sim, and they use Buck's language for the data analysis or Bayesian analysis. But actually, they face many problems in using Buck's. So what they did, they have developed a new language, and that is Stein. Stein, actually, the concept of simulation came in 1949 and 53. Stanley Ulmas and Metropolis, these are the two persons which gave the concept of simulation. They were the persons of statistical physics. Physicists have contributed a lot towards the development of statistical science and other sciences too. The father of Indian statistics, Prashant Chand Mahalanobis, he was basically a physicist. So they gave this concept. So Stanley Ulmas, to name him, they have taken the word Stan from there, and they developed Stan language. Nowadays, Stan language is basically, it has two implementations. The basic software is written in C++. So it is a C++ library, and it is a very powerful library. So they have developed it, and they have implemented it into R through an R-stand package, and they have provided an interface with the stand with Python also, and the name is PyStan. So if you want to enjoy Stan, actually, my students, all of my PhD students, they develop there. If you write a program in that, first it will be translated into C++, then it gets compiled, and then you get the executable file, and then you get the result. So because of that compilation, it is good for big data analysis. You know, Stan is good for big data analysis. There are two packages which I normally recommend. One is Stan, another one is INLA. INLA stands for Integrated Nested Laplace Approximation, which is being used in image analysis, in spatial statistics, in actually. So INLA is also a very powerful tool, and that is based on the concept of analytic approximation. That is not simulation. That is analytic approximation, but it works well for many complex data sets, and it is very fast. Actually, my own area of research is actually Bayesian statistics, and I used the concept of Laplace approximation. Basically, you know, Stirling's approximation, a factorial is nothing but it is an example of Laplace approximation, in which we approximate one dimension or multi-dimensional numerical integration problem by making use of comparing the integrand with the integrand of the multivariate normal. So that is a very powerful. Nowadays, people are using INLA package, and INLA, then there are some other packages too, like BR INLA. Recently, I delivered some talk in Tamil Nadu. There I talked about BR INLA, Bayesian regression with INLA. So that is also a very powerful tool for big data analytics. So I'm not going to talk about those things. So here, library, ARM, and display function, detail is equal to true. It makes a very clean output. So that's why I use the term smart didar of the function. It takes the object into a beauty parlor, cleans it. यहाँ देखिए कितना गंदा आउटपुट है ये, है ना? इसके मुकाबले में ये कितना चमक रहा है, जैसे लगता है कि ब्यूटी पार्लर से ही निकल के आया है. So look into the graphics. I've already talked about. This is the fitted object. Plot, you know, both are numeric, so it will generate the scatter diagram, and then abline we add. This is a high level function. This generate this scatter plot. Abline will add on the existing plot this line. It takes actually abline talks in terms of intercept as well as slope of the line. So it extracts from the fitted object, from this the beta r intercept, and then slope of the line, and then it plots. LWD line width and color of the line is red. So this is the twice of normal, thickness is twice of the normal, and this gives the red color to this. ये बड़ा R हमारा बहुत छोटा है, बड़ा स्मार्ट है, लेकिन ये बहुत रंगीन भी है. ये बहुत रंगीन भी है. देखेंगे, हम देखेंगे कितने रंग दिखा सकता है ये. कलर्स, you know, colors. How many colors option are there? 657 colors. Madam Shahnaz Hussain को भी नहीं पता होंगे इतने सारे colors. And actually, because of these coloring options, people used it in image analysis, in genetic mapping, in actually geographical information system, and there is a package by Deepayan Sarkar, that is Lattice package, that was made available to the users, and that is a part of the base library, Lattice. But later, Haley Wickham developed ggplot2. Romana was talking about GG formula, that is also a variant of ggplot2, which is the most elegant nowadays. देखा आपने कितने स्मार्ट ग्राफिक्स थे. सिंपल अगर आप उसमें अपने हिस्टोग्राम भी बनाएंगे तो वो भी बहुत जबरदस्त लगेंगे. लगता है कि बहुत टॉप ब्यूटी पार्लर से होकर के आ रहा है. So these are the color options available with R, and that makes your graphics excellent. ये तो बहुत काला पीला है, ये बेस ग्राफिक्स है. Base graphics which was due to Robert Gentleman, and then Lattice, which is a multivariate graphic package due to the Dipayan Sarkar, that is also being used for geographical information system and image analysis, etc. And the most elegant nowadays is due to Heli Wickham, and that is ggplot2. See, I'm just using a polynomial regression, which is very simple thing. The formula here, earlier up to this one, beta naught plus beta 1x, this is the simple linear regression. And actually, we are adding one more term, and that is x raised power 2. Here, insulator operator we are using because, you know, this operator is for formula, but this one is for computing. So it makes squares of base 2, and then it fits. Okay. From the graph, it shows that it should be like a polynomial. So that's why we guess, and we are using the same function. LM is being used, and we are fitting the polynomial. We are getting the result, and we are plotting them by using the function coef m11. This is the first. This is the beta 1, beta naught. This is the beta 1, and this is the beta 2. And we are using the function curve. See, this is the intercept, the first, and this is the coefficient of x, and this is the coefficient of x square. Add is equal to true. This one will make the scatter diagram, and this will add the curve. This curve function is very powerful. And then similarly, we can go for multiple linear regression analysis also. Here, you know, these are the default which we get into these, but if you want that there should be a linear regression line in each panel between batch A and batch B, the trend is like this. Between batch A and batch C, the trend is like this. So how these linear lines will be fitted? You can write a simple function. I've written a function pan1. These are the panels. So for each panel, you can make use of this function. See, this is pan1, the function x and y. These are the arguments. M1, we are fitting a simple linear regression line, y versus x. Points, to add the points in these panels, x and y, add points, f line to add the lines. We are dumping it and we are sourcing it. Now the function pairs, which we used here to get this pairs, this is known as pairs plot. Here we are using the function panel is equal to pan1, and pan1 is this which returns these, which returns this kind of graphics. So we are using and we are getting the result, which is meaningful. And we can make use of, you know, this R has a large number of data sets inbuilt with it. You know, there is a package data sets which is available with R that has a large number of data sets. But if you contribute, you know, more than 14,000 packages are available with R in the form of contributed packages. And every package has its own data set. So a big data is available, a big number of data sets are available with R, and you can see that data, the function which are available with data set package. This is data trees, and this is the data. So this is the data. You can have detail about this data, like just type help date trees. So it is showing. हम थोड़ा सा इसको बड़ा तो कर सकते हैं, लेकिन चाह नहीं रहे ज़्यादा बड़ा करना. This is available in datasets package, and these are the details. Description of the data, then the object trees. The format is a data frame with 31 rows and 3 variables. That is the girth, height, and volume of cherry trees, and this is reported by Ryan et al. In the manual of Minitab software, and this is reported by Atkinson AC, Plots, Transformation and Regression, Oxford University Press. And these are the certain examples of these. Example function is also there in R, through which you can read, you can get these examples run on the screen. So, sorry. So this data set, you can just type data to load the data, names to see the names of the column names, and then print trees. You have got this data seen here. You can use that data to fit this multiple linear regression model, volume versus girth plus height, and data is equal to trees. And we are getting the result. See, girth is statistically significantly related with volume, height is also significantly related with volume. This is a very simple example of how to model this data. Then display, we are using the function display to display the result of ARM, and we are getting this result. And here we are again using the function pan1, which we have defined. We are calling that in pairs, and we are getting this graph. So it is because of the function pan, which we defined here, and we have saved it. So you can implement your own ideas. Actually, programming in R is nothing but defining new function, and using that, we have defined many functions for actually implementation into the stand to get the simulation done and to get the methods for many complex models of survival models for medical data, as well as for medical data. Yasmin did her work, and Romana did her PhD. Developed many functions for implementation into R. So that is the main contribution towards us, towards our side. ये देखिए, creation of a data frame from Excel. Microsoft Excel वालों को हम कहते हैं ये मैके वाले हैं. मैके वाले क्यों हैं? You know, there is a book by Harry Maddox which says how to study. At that book, I always refer in my talks. That is an excellent book, and I have made a photocopy available in our seminar library, and the same book in the form of photocopy is available with the staff college library also. That is a 200-page book, and that is a very good book, how to learn and how to study. So that is a very good book. So in that book, Harry Maddox says that if you are able to relate your advanced knowledge with the existing simple knowledge, you shall be able to communicate in a very excellent manner. So people are familiar with Excel, understand. So if you are able to create your data frame into Excel, just it is very simple. Creation of data frame into Excel, it is very simple in R. Simply enter your data into Excel spreadsheet. First row should be the name of the variables. Save it as comma delimited values. वहाँ option आता है हमारा. If the data is in the format, save it as CSV file and use read.csv. So we have created a CSV file, this data into Excel spreadsheet. We have saved it as .csv file, and we can directly call into R by using the function read.csv. And this is the data frame dat1. So this way you can create your data into Excel and you can call it into R. It is very simple. If your data is available with, say for example, Stata, there is a library foreign in R, that is a package in which they have provided the function. The function for reading Stata file is read.dta, and your file extension of Stata should be with DTA extension. Similarly, if your data is saved into SPSS, you have to use the function read.spss, and you give the function here with the additional argument as .data.frame. So you will get translated that data. Similarly, you can call data from other softwares like SAS, है ना? ये मैके वालों को भेजता भी है और मैके वालों से ले भी लेता है. ये बहुत इसकी बड़ी खूबी है. So this way you can enter data into Excel and you can read it into R. I think I should stop here because I have talked about the nonlinear model. The function is NLS. It is also very simple. This is the nonlinear model. The function is NLS. We have written the formula. You can read all these things, and we have made the plot also. Then Yasmin was talking about the apply group of function, T apply, S apply, L apply. These are very powerful functions for the purpose of, I have made simple illustration of all these things, and these are very useful from the purpose of programming viewpoint. So you can learn then statistical analysis of categorical data. I have created a data and I have made these data sets analyzed in a very simple manner. So I think I should stop. I am not going to discuss logic model. In logistic regression model, our output is not continuous, it is categorical. Input can be continuous as well as, but the main thing is that our output should be binary. So then we can use logistic regression model that has been implemented into R. The function is glm. So I have made an illustration of all these things. You can learn from these things, you can implement them. Survival analysis, your reliability data and survival data can be analyzed by the package survival, which is a very powerful function, powerful package. And actually you can analyze your data generated. Even say, for example, nowadays, if corona becomes, a person becomes infected corona, then there are many things, whether he was infected into the first wave or second wave, then what is the probability of survival, how long he will survive, what is the probability of death. So all those things you can analyze by using the function, by using the package survival. We teach survival. Yasmin did her PhD in survival analysis using Bayesian tools. So the package survival is available with R. There are many other packages and there are many other things. If you go on the home page of Google, type on Google CRAN R, you can get all those things. I would like to show just the home page of that. देखिए हम सीधे चले जाएं CRAN पर. CRAN पर हम गए, एक मिनट. हम जरूर दिखाना चाहेंगे CRAN R, comprehensive R archive network. So here there are many things available, like this is the home page of comprehensive R. You can download R for Linux, then for Macintosh, for Windows, and these are the different mirrors. These mirrors are available all over the world. You can download from cloud also. What is new? Then task view. I wanted to talk about task views. So these are the different task groups, like Bayesian statistics, then ChemFace, clinical trials, cluster, databases, differential equations. देखिए आप तमाम हैं इसमें. मशीन लर्निंग देख रहे हैं आप. आजकल कंप्यूटर वाले मशीन लर्निंग की बातें बहुत कर रहे हैं. सो दीज आर दी पैकेजेस. कल कोई पूछ रहा था मुझसे डीप लर्निंग के बारे में. ऑल दीज आर दी पैकेजेस ऑफ डीप लर्निंग. ये सारे के सारे जो ये नजर आ रहे हैं, दीज आर दी पैकेजेस ऑफ मशीन लर्निंग. ये देखिए आप, and they have classified them. You can look into any of these, and these are E1071. This is a package which is the core package. Out of all these, only a few are core packages. Like this package E1071, this is a very powerful package which gives the Bayesian parallel the analysis of structural equation models, confirmatory factor analysis, everything. Lavan package is there. So all these packages, you can have their manuals, everything. Like देखिए अब हम आपको दिखा रहे हैं यहाँ पर this E1071. See, this is miscellaneous functions of the Department of Statistics Probability Theory Group E10 TU. Functions for latent class analysis, short time Fourier transformation, support vector machines, shortest path computations, back clustering, then Bayesian classifier, generalized k-mean, etc. And actually here this is the manual, this is the PDF manual, and these are the vignettes. Vignettes means these are the articles which are available with the package. You can read them. You can see the whole manual also. See, this is containing 66 pages. You can download this manual and you can print it and you can learn all these things from this manual also. So this way you can have the things. आगे हम टास्क व्यू पर इसी तरह से तमाम चीजों के बारे में, फार्माकोकाइनेटिक्स, ऑप्टिमाइजेशन ऑफ न्यूमेरिकल एनालिसिस, मल्टीवेरिएट एनालिसिस, मॉडल डेवलपमेंट, मिसिंग डेटा एनालिसिस, मिसिंग डेटा की बात हो रही, मेटा एनालिसिस, मेडिकल इमेजिंग, hydrology, high performance computing. We have hundreds of softwares and you can make use of them. Teaching statistics, time series, web technologies, So all these things are available. All these are the different task groups in which you have hundreds of softwares, at least with an interface with R Markdown. There are two packages which I would like to mention of XyY. XyY is the developer of R Markdown, which we use for documentation. They have written certain extensions of these, and they are, one is book down, which is meant for writing articles and books, etc., for documentation. One is blog down, a book written by Zai and his team. That is a book which facilitates understanding of how to develop a website using R Markdown. और भी हैं इसमें बहुत सारी चीजें, लेकिन जाहिर सी बात है कि सारी चीजें हम दिखा नहीं सकते, है ना। लोग मुझसे पूछते हैं कि साहब आप एक लेक्चर में क्या दिखाएंगे, कितना दिखाएंगे 2 लेक्चर्स में। देखिए साहब, हम आर सिखाने नहीं आए हैं। Here we are, once a big gathering was chaired by a very senior person, and that was a training program. So people asked from him that how you will train large number of people in these some lectures. What he replied to them: I am not training, I am not giving a lecture on how to ride a bicycle. I am giving you the bicycle and you will take it and you will learn how to ride. So I am giving you a bicycle of R, and you will know later that how to ride on it and how you will enjoy those things. So these are my last words. I thanks for the patience, and I'm thankful to the organizers for giving me a chance to speak. Thanks. I think I should stop. ये क्या हुआ? Hello. Hello.
Yes, sir, you are audible.
Yeah. हाँ जी, अब हमने बंद किया, और अब क्वेश्चन कुछ पूछना अगर चाहें, कोई सवाल करना चाहें। मुझे लग रहा कि मेरा स्क्रीन जो है वो है ना, अब स्टॉप शेयरिंग।
You stop sharing, but you are audible. Audience, the participants may please ask questions if there are any.
Yeah. वरना हमारा ईमेल आईडी है, जिसको कुछ पूछना हो ईमेल पे पूछ सकता है। मेरा फोन नंबर भी है डिपार्टमेंट का और अपने मोबाइल का भी। If you want to ask something, you can ask from there too. Yes.
Anybody?
चलिए।
Anyway, thank you very, very much, Professor Athar Ali Khan sir. You have made the things so easy, so simple for our participants, and your presence has definitely encouraged all of us, and I'm very sure that they'll what they have learned from you, they'll definitely put that to practical use, and it will benefit them a lot in future.
Inshallah.
We now stop here for 5 minutes. After 5:35, we'll start another session. So you go and have a cup of tea. We come back in 5 minutes. Thank you.
Okay. Thanks.